So the next type of polar curve that we're going to look at is the rose curve. Now, if you look at the two polar equations for the rose, they look very similar to the circle. The difference here is theta is going to be multiplied by an integer that's greater than 1. So it's going to be something like sine of 2 theta, cosine of 5 theta. Could be 3 sine of 2 theta, 7 cosine of 5 theta. Now, a rose will have petals. If n is odd, the rose has n petals. If n is even, the rose has 2n petals. So just for an example, okay, I'm going to be posting this worksheet. Here are examples of rose curves. Now, if you notice, when n is 2, you have 4 petals. Now, a petal, that's 1 petal. This is a second petal. This is a third petal. This is a fourth petal. When n is 3, you only have 3 petals. When n is 4, you have 8 petals. When n is 5, you have 5 petals. Now, what's going to be important about graphing a rose curve is knowing how many petals there are, where the largest, I shouldn't say largest, but the longest part of the petal. We're going to figure out what that is. You need to know how long the longest part of the petal is and that amount of degrees of rotation. So what is that angle? What is that angle? The angle at the tip of each petal. Then you'll be able to draw any rose as long as you know that information. So let's go back, and why don't we look at graphing? Let's do r equals sine of 2 theta. Now, when you don't know at first what type of polar it is, what you do is what we've been doing so far, where you graph it, where we put theta here, we put r here, and what we're looking for is the relationship of when theta is a given measure, what is r? And then as we increase theta, seeing what's happening to r, because you have to graph the polar equation on the polar coordinate plane. So this isn't the polar coordinate plane. This is just allowing us to think about what r is going to be at a given theta. So it gathers the data so that we could plot it on the polar curve and kind of make sense of it. So what we're going to want to do here, okay, is think of this as just graphing y equals sine of 2x, right? That's what we first started doing in trigonometry. So we know if we're graphing y equals sine of 2x, okay, few things we'll go through right now. We know that this isn't going to have the same period as the parent because we are multiplying our input of x by some value. So we can do this in degrees, okay? So the parent period is 360 degrees, and we are not going to have the same period because we're multiplying x by 2. So remember, period is 2 pi over b, but since we're in degrees, 360 over b, and b is 2, so 360 over 2, so this goes through one cycle in 180 degrees. So this thing is moving faster through its cycle than its parent. Now, other points that I want to discuss right now are what is the maximum value that y can be, and what is the minimum value that y can be? Because what's going to tell us is what's the largest value r can reach, what's the smallest value r can reach. So if you think about this, this is saying we're going to multiply the angle by 2, and then we're going to take sine of it. And we're not going to do anything after that. So the maximum value that sine can be is 1. The minimum value that sine can be is -1. Now, what's going to be important with graphing rose curves are finding what are those specific values in which sine is the maximum, in which sine is the minimum. So this involves inverse trig. Inverse sine of 1 equals 2x. When does sine evaluate to be positive 1? Well, that's 90 degrees plus everything coterminal. When does sine evaluate to be negative 1? Well, that's 270 degrees plus 360n equals 2x. Let's see if I have enough room to write that down. Plus 360n equals 2x. Okay, and so now we have to divide by 2, so that's going to give us 45 plus 180n equals x, and divide by 2, 135 degrees plus 180 degrees n equals x. So we're going to have 45, and then 180 plus 45 is 225. 135, and then 135 plus 180 is 315. So those are going to be 4 measures that are not coterminal with each other, that either give us the maximum length or the minimum length. So we're going to want to keep those in mind, those 4 values. Now think about this. Look at what n is. N is 2, and I just said think of those 4 values. So what I'm going to do right now is I'm going to make a table of values, and I'm going to get y equals sine of 2x up here. So I specifically chose these thetas because it's going to allow us to capture all of the maximums and the mins, and it goes from 0 to 360 degrees, which is 1 full rotation, if you think about it, 1 full rotation around the polar coordinate plane. And so now I will fill these values in. You will not be responsible for making a table of values when you are graphing these rose curves. Okay, I'm just doing this so that you can see what this graph will look like in depth. So this is what the graph looks like. No surprise, this is what you're used to doing in trigonometry. Now, what I want you to be mindful of is, notice what r is as we increase theta. So when theta is 0, now think about this in terms of the polar coordinate plane, okay? Here's our polar coordinate plane that we've got going on here, okay? So when theta is 0 degrees, r is 0. Then, as theta goes to 45 degrees, okay, as theta goes to 45 degrees, r is growing to 1. And then from 45 to 90, r is going back down to 0, a radius of 0. Then at 90 degrees to 135 degrees, r is negative and then hits r is negative 1. And then remember what that would look like on a graph. That just means r negative 1 really means r is 1, but you're taking this angle and just adding 180 degrees to it. Then r is going back down to 0. Then, until 225, r is going back up to 1, and then it's going to go back to 0. Down to negative 1, back to 0. So what we're going to want to do right now is plot it on the polar coordinate plane. So we're going to take these points and use them on the polar coordinate plane. So I drew my own polar coordinate plane, so it's a little bit off, but let's go through this. So the points that I said are really important were those 4 points. Notice the largest r value that we're going to get is 1. That shouldn't be a shock because what's the largest output that this can give us? 1. Now, 0 degrees rotation, it's 0. So that's right here. At 45 degrees, r is 1. Now, from 0 to 45 degrees, we need to know what should we do as we rotate from 0 degrees to 45 degrees. Well, look here. What's happening to r as it goes from 0 to 45 degrees? It's going to 1. So that means it goes like that. Then at 90 degrees, it's back at 0. Now look at what's happening to r. From 45 to 90 degrees, it's going from a radius of 1 down to a radius of 0. So from 45 degrees and at 90 degrees it's at 0, you just made your first pedal. What that pedal is r is going up to its maximum and then it's falling back down to 0 because that's what's happening on that curve right there. Then we've got 135, and R is -1. So what's going to have to happen here is you're going to want to rewrite that. So look, it actually becomes, all of these negatives actually become the maximums as well in terms of a polar coordinate plane, because we're going to add 180 to 135. And so we get 315. So we're going to plot 1, 315. So, I kind of made this drop a little. So 315 degrees is right here. And at 315 degrees, we're going to be at 1. So let's see what we got next. 180 degrees is 0. So when I'm at 180 degrees, I'm at 0. When I'm at 225 degrees, I'm at 1. Now, let's look. 180 to 225. What's happening there? So here's 180. Here's 225. R is growing to 1. And then to 270, it's going back down to 0. And look, 270, it's at 0. So it's going up to 1, and then it's coming back down to 0. And then, if you look, 270 to 315, okay, 270 to 315 are all of those -1s. Sorry, it's all of these negatives down to -1. So it would actually be the opposite values. All of these would be in between here. You would have to add 180. So that's what's giving you this last sorry, I shouldn't have said last. That's what's giving you this curve down here. Okay, so now I said last, but I shouldn't have yet. I was just looking over here. Okay, 270 to 315, we're at those negatives, right? And then at theta is 315 degrees, R is -1. So we've taken care of this, we've taken care of this, we've taken care of this. We now need to take care of that point. So -1, 315 degrees, I have to add 180 to make that a positive R. So that gives us 495. Now we would probably want to think about that coterminal just so it's easier to draw. You'd have to rotate one full time and a little bit more. 495 minus 360 is 135. So that's the point 1, 135 degrees. Okay, so that would be right here. And that's going to be our last petal that we've got going on. So notice, the largest length of the petal is 1. And you hit the largest length of the petal at those values that gave you 1 and -1. That is your rows for R equals sine of 2 theta. Notice you have 4 petals. N is 2 gave you 4 petals. So what you'll be responsible for doing is making the graph by figuring out where the petals are going to be, how many petals you're going to have, and the length from the center to the tip of the petal.